Hello students, let us continue the MCQ series. If you see question number 7 here, weight of one atom of an element is given and what is the number of atoms of the element? They are asking for 40 kg of it. Now let us see the options what they have given. Options, if you see, they have given 10 raised to 3 gram atom, 10 raised to 2 gram atom, 10 raised to 4 gram atom and 10 gram atom. Means they are asking you to calculate the total number of atoms present in that mass. So let us start for the problem. So students, given number of atoms, if you see given number of atoms in the question, they are asking for one atom, so that is equal to 1. Weight of one atom they have given, that is 6.644 into 10 raised to minus 23 gram. Now here we need to calculate atom, so number of atoms is equal to, what is the formula student? Number of moles into Avogadro number into atomicity. Here number of moles are not given, therefore I will split this number of moles as number of atoms. What they have given is 1. So 1 is equal to given mass of that particular substance divided by its molar mass or molecular weight multiplied by Avogadro number 6.023 into 10 raised to 23 multiplied by its atomicity. Now what is the atomicity they have given student? Atomicity is 1, right? So I'm shifting this to this side, so it will be given mass is how much is this. So let us substitute and rearrange the equation. So molar mass of the substance is equal to, given mass is 6.644 into 10 raised to minus 23 multiplied by Avogadro number into 10 raised to 23 multiplied by atomicity, and I'll divide this by the number of atoms, that is 1. If you calculate this will give you nearly 40 gram mole. Right students? Now how much they are asking for? They are asking the mass for element in 40 kg. So let us convert this 40 kg to 40 gram. So therefore number of atoms will be equal to, given mass or asked mass is 40 kg multiplied by this, it will become gram divided by 40 gram mole, what I have calculated here. Right students? So this is given mass upon the molar mass. If you calculate this, you get 10 raised to 3 atoms. So here answer is 10 raised to 3 gram atom, that is first option. Let's see the next question. Question number 8. Molar mass of electron is nearly, they have given Avogadro number there in the bracket. So let us see what is the mass of an electron is how much student? 9.1 into 10 raised to minus 31 kg. Right? They are asking for Avogadro number, therefore mass of Avogadro number of electrons, therefore mass of 6.022 into 10 raised to 23 electrons will be how much? Simply cross multiply this, you will get 9.1 into 10 raised to minus 31 multiplied by Avogadro number, and this will give you 54.8 into 10 raised to minus 8. Now students, if you see the options, option C is also 54.6, near to this is also 54.6, but now if you see the unit here, this is kg, so the answer will be in kg. So answer here is fourth option, that is 54.8 into 10 raised to minus 8 kg mole inverse. Right students? So answer will be your fourth option, that is D option. See the next question. Question number 9. Volume of a gas at NTP is 1.12 into 10 raised to minus 7 cc. The number of molecules in it will be. Now students, here they are asking you about the normal temperature pressure condition. So let us write our standard equation. Here they have given the volume. So let us calculate the standard volume. So it will be, you know that 22400 cc or cm cube of the gas must contain Avogadro number of molecules, right? Therefore, the given volume, that is 1.12 into 10 raised to minus 7 cubic centimeter will correspond to how much? What will be the number of molecules? So let us cross multiply this. So that will be 1.12 into 10 raised to minus 7 multiplied by 6.022 into 10 raised to 23 divided by 22400. If you solve this, you will get the answer as 3.1 into 10 raised to 20. So here answer will be first option, that is A, 3.1 into 10 raised to 20. See the next question. The number of moles of a compound, they have given this compound in its pure sample. So you have to calculate that how many oxygen moles will be present in that particular given question. Now students, if I write Al2SO4 thrice, then how you calculate the number of oxygen atoms? You multiply this 4 and 3. So here oxygen will be 12 in number, right? If I want to calculate the oxygen atoms. Same concept we'll be using for this. If I write the formula of the compound they have given, KHC2O4, and there is a bracket like this 0.95. Non-stoichiometric compound is given. So H2C2O4, this is oxalic acid. Right student? If I want to calculate the total number of oxygen here, so how much will be? This is 1 mole of the compound which is given. So in 1 mole of the compound, number of oxygen atoms or number of oxygen atoms will be how much student? The number of oxygen atoms will be, see how I am doing this, will be 0.94 multiplied by 4. So it will be 4 multiplied by 0.95 plus 4 oxygen atoms. From where I got this 4 is this. This is 4, and for this I will multiply the same pattern like we multiply in this type of compounds. So it will be 4 multiplied by 0.95. If you do the calculation here, you will get a total of 7.8 moles. Right student? Now, for 1 mole of the given compound, how many moles you have? Is 7.8 moles of oxygen. Therefore, for 4 moles, it will be how much? So it will be equal to, now if you see this, for 1 mole of this, it will be 1 upon 7.8. For 4, it will be how much? So it will be 1 upon 7.8 multiplied by 4. But students, if you see the options, there is no option related to this, and therefore without doing the calculation for this, we will keep those moles as it is. So what will be your answer? It will be 4 divided by, now I will not solve the total number of moles, so it will be 4 divided by 4 multiplied by 0.95 plus 4. So here your answer is third option. If you see this, it is third option. So students, please like the video if you really gain some knowledge from this, and please subscribe to get more videos based on MCQs. Thank you students.